Great architecture starts with one simple rule: respect the forces that will test it. Number 1. Location. Take a tour of your site and its surroundings. How do the forces of sun, wind, and rain impact the site? Observe features such as site drainage, topography, vegetation, availability of municipal utilities. Understand the soil, water table, flood risk, protected areas, wetlands. Locate utilities, easements, right-of-ways, and site structures on and adjacent to the site. Research zoning and code impacts such as setbacks, material or height restrictions. Look into the future. Are there construction projects planned which might affect your site? And review site features and constraints before you fall in love with the site plan. Number 2. Expansion and contraction. Materials move. If you don't plan for building and material movement, for example, building settlement, uplift, and deflection can occur, leading to cracks, structural problems, and water damage. Identify construction and control joint locations. Before finalizing the design, joints are just as big a part of the design as the massing. Number 3. Seismic. The USGS, for example, rates land from low to high risk, providing hazard maps to help in land use planning, mitigation, and emergency response. Ground shaking is the main cause of damage to buildings. Factors like the earthquake strength, magnitude, proximity to a fault, local geology, and soil type all influence the building design. Review the building's configuration and detail connections, so the structure can dissipate energy, not collapse. Be smart. Coordinate the building design with a structural engineer in pre-design. Understand how seismic will influence the design early. Number 4. Wind. Wind loads, pressure differentials, cladding attachment are non-negotiable. Test for uplift and local turbulence, especially around corners and openings. Look around the community for building designs and materials that have survived major wind events in the area and incorporate those lessons into your designs. Number 5. Sun, solar heat, and glare. Shape, comfort, and energy use. For example, window U factors, SHGC ratings, orientation, size, material, shading, and details work to influence the sun's impact on a building's energy efficiency. In combination with the R value of the exterior wall assembly, both work to meet comfort, energy, and building sustainability goals. Design openings and walls with intention, not just for aesthetics or views. Number 6. Materials. Compatibility matters. Don't pair metals that corrode each other or finishes that outlast their substrates. Think about the material's longevity, maintenance, and recyclability. Select materials with a knowledge of their properties, not just their aesthetics. Number 7. Insulation. Insulation properties and how we insulate impact a building's thermal, moisture, and acoustic performance. If you think there is little difference between insulations, think again. Does your project call for a simple thermal enclosure, or do you need to consider acoustic or air sealing issues? What about cost? Each form of insulation has its positives and negatives, for example. Batt insulation is cost-effective, but can suffer from poor performance, due heat or cold conduction through structural elements. But the glass fibers can also irritate lungs, eyes, and skin. Blown insulation is another option, and is the least expensive. But if it becomes wet, mold and reduced performance can result. Foam insulation costs more, but its R value and air sealing properties are better. But as it is derived from a petroleum product, health and environmental concerns can be negatives for some clients. These days, picking an insulation type is not without challenges. For over 25 years, building codes have required an energy analysis to ensure the building design will meet energy performance minimums. As such, selection of insulation and other materials is critical if a building is to be approved for a permit. Address the 7 items and your building design should succeed technically. But since architectural design is more than just technical details, buildings can still fail if function, needs, budget, or other project issues are not addressed and fail to meet the project's goals. Remember, architecture is more than just the details. It's a look into the soul of the architect, his client, and users.